today we're going to look at what inscribed angles are in a circle. So far in class we've been talking about what some type of angle, but these angles always went from one side of the circle to the center, and then the other side from the center to the other side. And these were called central angles. And the reason that they were called central angles was because the vertex was in the center. The vertex was at the center. So what we're going to talk about today is, okay, what if we have this different type of angle that goes from one side of the circle to the other, but now all of a sudden it's no longer having the vertex at the center? What is that called? Well, that's actually going to be called an inscribed angle, because an inscribed angle is an angle in the circle where the vertex lies on the circle. So the vertex is lying on the circle, which we see in this case where the vertex, the part where the two sides of an angle come together, is in or on the circle. So if we look at an example of this, here's one. We could draw another one here where, maybe this one goes through the center, but the vertex does not lie on the center. That's okay. Remember, the vertex is where those two sides of the angle meet. So here's the vertex again lying on the center. Well, what would we call the sides of this? So if we say, okay, we have the sides of this inscribed angle, but what those sides are called is they're called chords, if you remember that from when we went over circle definitions. Was a chord goes as a line segment that goes from one side of the circle to the other. So now let's look at, okay, well, great, we know what an inscribed angle is, but how do I find the measure of either the inscribed angle or its intercepted arc? Which, let's take a second. Wait, what does that word intercepted arc mean? So if we look at this one here, we have this angle of 50 degrees, and it's an inscribed angle because both sides are chords. They go from one side of the circle to the other. And in this case, we would know what that angle is. It's given to us. So we know that ABC is 50 degrees. So now what it's asking is, could we find its intercepted arc, which that means the arc that would connect the two chords. So the arc that would connect A to C in this case, or the ends of the two chords. So what this reads is the measure of the inscribed angle equals, and that's going to be equals 1/2 or half of the measure of the intercepted arc. So if we go the other way, right, we could say, right, the angle is half of the arc. Or the way we could turn this around is the arc is double the angle. So if we think about this first problem here would actually follow the second one down here. It would follow the arc is double the angle. So if I know the angle is 50, the intercepted arc above it would be 100 because it's just 2 times that angle, or double the angle. So if we just look at another example here, okay, here's our angle that we have. We're looking for DEF. That's our angle measure. So that would be 22 degrees. Now we're looking at, okay, if I come down here, DF, that's its inscribed angle. So DF would just be double the 22. So that's 44 degrees. And you can kind of see what I'm doing here is, what I like to always think of is I'm making these ice cream cone like shapes. Sometimes they might look a little weird, but it always has 2 straight ends and then an arc on top, so it kind of looks like an ice cream cone. So if you think, as we just keep going, okay, well, this one's a little bit different. Now I'm given the arc, so I'm given 96 degrees. Well, now it's asking me for that angle, GHI, so the angle on the inside. Well, remember, okay, to find the angle is half of the arc. So I would take that 96, we would divide by 2. If we do some long division here, we get 16. So 48, excuse me. Right, so 48 degrees, right? And we can keep doing this from one step to the next, right? In this one, okay, let's see. I have the angle Now, how would I find the arc? JL. So here we go, JL. So that would be then double the angle. So if you're given the angle, you just double it, and that finds the arc. If you're given the arc, you have to take half of it to get the angle. So let's move on to page 36 if you're following along with the packet I gave you. And let's just look at a couple problems here. So this one, if you look at it, okay, I'm given the angle, asking to find the arc. So that means x will be 2 times 40, which is 80 degrees.